Food energy is energy that animals derive from their food, through the process of cellular respiration, the process of joining oxygen with the molecules of food, or of reorganizing the atoms within the molecules for anaerobic respiration. Humans and other animals need a minimum intake of food energy to sustain their metabolism and drive their muscles. Foods are composed chiefly of carbohydrates, fats, proteins, water, vitamins, and minerals. Carbohydrates, fats, proteins, and water represent virtually all the weight of food, with vitamins and minerals making up only a small percentage of the weight. Carbohydrates, fats, and proteins comprise 90% of the dry weight of foods. Food energy is derived from carbohydrates, fats and proteins, as well as organic acids, polyols, and ethanol present in the diet. Some diet components that provide little or no food energy, such as water, minerals, vitamins, cholesterol, and fibre, may still be necessary to health and survival for other reasons. Water, minerals, vitamins, and cholesterol are not broken down and so cannot be used for energy. Fibre, a type of carbohydrate, cannot be completely digested by the human body. Ruminants can extract food energy from the respiration of cellulose thanks to bacteria in their rumens. In the International System of Units, energy is measured in joules or its multiples. The kilojoule is most often used for food-related quantities. An older metric system unit of energy, still widely used in food-related contexts, is the calorie. More precisely, the food calorie, large calorie, or kilocalorie, equal to 4.184 kilojoules. That is often used in chemistry and physics, equal to 1/1000th of a food calorie. Within the European Union, both the kilocalorie and kilojoule appear on nutrition labels. In many countries, only one of the units is displayed. In the US and Canada the unit is spelled out as calorie, or calorie. Fats and ethanol have the greatest amount of food energy per mass, 37 and 29 kilojoules per gram, respectively. Proteins and most carbohydrates have about 17 kilojoule per gram. The differing energy density of foods lies mainly in their varying proportions of carbon, hydrogen, and oxygen atoms. Carbohydrates that are not easily absorbed, such as fiber, or lactose in lactose-intolerant individuals, contribute less food energy. Polyols and organic acids contribute 10 kilojoule per gram and 13 kilojoule per gram respectively. The amount of water, fat, and fiber in foods determines their energy density. Theoretically, food energy could be measured in different ways, such as Gibbs free energy of combustion, or the amount of ATP generated by metabolizing the food. However, the convention is to use the heat of the oxidation reaction, with the water substance produced being in the liquid phase. Conventional food energy is based on heats of combustion in a bomb calorimeter and corrections that take into consideration the efficiency of digestion and absorption and the production of urea and other substances in the urine. These were worked out in the late 19th century by the American chemist Wilbur Atwater. See Atwater system for more detail. Each food item has a specific metabolizable energy intake. This value can be approximated by multiplying the total amount of energy associated with a food item by 85%, which is the typical amount of energy actually obtained by a human after respiration has been completed. In animal nutrition, where energy is a critical element of the economics of meat production, a specific metabolizable energy may be determined for each component of each ingredient of the feed. Nutrition labels. Many governments require food manufacturers to label the energy content of their products, to help consumers control their energy intake. In the European Union, manufacturers of packaged food must label the nutritional energy of their products in both kilocalories and kilojoules, when required. In the United States, the equivalent mandatory labels display only calories, often as a substitute for the name of the quantity being measured, food energy. An additional kilojoules figure is optional and is rarely used. The energy available from the respiration of food is usually given on labels for 100 ag, for a typical serving size, and/or for the entire pack contents. The amount of food energy associated with a particular food could be measured by completely burning the dried food in a bomb calorimeter, a method known as direct calorimetry. However, the values given on food labels are not determined in this way. The reason for this is that direct calorimetry also burns the dietary fiber, and so does not allow for fecal losses. Thus direct calorimetry would give systematic overestimates of the amount of fuel that actually enters the blood through digestion. What are used instead are standardized chemical tests or an analysis of the recipe using reference tables for common ingredients to estimate the product's digestible constituents. These results are then converted into an equivalent energy value based on the following standardized table of energy densities. However, energy density is a misleading term, for it once again assumes that energy is in the particular food, whereas it simply means that high-density food needs more oxygen during respiration, leading to greater transfer of energy. All the other nutrients in food are non-caloric and are thus not counted. Recommended daily intake. Recommendations in the United States are 2,700 and 2,100 a kilocalorie for men and women between 31 and 50. At a physical activity level equivalent to walking about 2 to 5 km per day at 5 to 6 km per hour, in addition to the light physical activity associated with typical day-to-day life, with French guidance suggesting roughly the same levels. Children, those with sedentary lifestyles, and older people require less energy. Physically active people more. In Australia, because different people require different daily energy intakes, there is no single recommended intake. Instead, there is a series of recommendations for each age and gender group, although packaged food and fast food outlet menu labels refer to the average Australian daily energy intake of 8,700 kJ. According to the Food and Agriculture Organization of the United Nations, the average minimum energy requirement per person per day is about 7,500 kJ. Increased mental activity has been linked with moderately increased brain energy consumption. Energy usage in the human body. The human body uses the energy released by respiration for a wide range of purposes. About 20% of the energy is used for brain metabolism, and much of the rest is used for the basal metabolic requirements of other organs and tissues. In cold environments, metabolism may increase simply to produce heat to maintain body temperature. Among the diverse uses for energy, one is the production of mechanical energy by skeletal muscle to maintain posture and produce motion. The conversion efficiency of energy from respiration into mechanical power depends on the type of food and on the type of physical energy usage. In general, the efficiency of muscles is rather low, only 18 to 26% of the energy available from respiration is converted into mechanical energy. This low efficiency is the result of about 40% efficiency of generating ATP from the respiration of food, losses in converting energy from ATP into mechanical work inside the muscle, and mechanical losses inside the body. The latter two losses are dependent on the type of exercise and the type of muscle fibers being used. However, alterations in the structure of the material consumed can cause modifications in the amount of energy that can be derived from the food. That is, caloric value depends on the surface area and volume of a food. For an overall efficiency of 20%, 1 watt of mechanical power is equivalent to 4.3 kilocalorie per hour. For example, a manufacturer of rowing equipment shows calories released from burning food as 4 times the actual mechanical work, plus 300 kilocalorie per hour, which amounts to about 20% efficiency at 250 watts of mechanical output. It can take up to 20 hours of little physical output to burn off 4,000 kilocalorie more than a body would otherwise consume. For reference, each kilogram of body fat is roughly equivalent to 32,300 kilojoules of food energy. In addition, the quality of calories matters because the energy absorption rate of different foods with equal amounts of calories may vary. Some nutrients have regulatory roles affected by cell signaling, in addition to providing energy for the body. For example, leucine plays an important role in the regulation of protein metabolism and suppresses an individual's appetite. Swings in body temperature either hotter or cooler increase the metabolic rate, thus burning more energy. Prolonged exposure to extremely warm or very cold environments increases the basal metabolic rate. People who live in these types of settings often have BMRs 5 or Euro 20% higher than those in other climates. Physical activity also significantly increases body temperature, which in turn uses more energy from respiration. See also, chemical energy, basal metabolic rate, food chain, Atwater system, nutrition facts label, heat of combustion, calorie, food composition, references. External links, FAO Food and Nutrition Paper 77, Food Energy, Methods of Analysis and Conversion Factors, Is a calorie a calorie?